I've had this Yamaha RN-301 network receiver for about a year now. I originally brought it because if we look at the back panel here, you see it's got a DAC in it, both optical coaxial, multiple line-ins. You've got the network connector, so it will do Apple AirPlay, it will do Spotify and various other things. You either plug a little Wi-Fi receiver into that, or you can just plug your lead straight from your router into it. To be honest, I don't like it's clunky trying to use the the on-screen display to try and find radio stations and stuff. Doesn't seem to work particularly well with the various apps, so I actually just have a Google Chromecast audio plugged into it. I don't have any Apple devices, so the lack of AirPlay compatibility with the Google Chromecast audio doesn't particularly bother me in the slightest. Anyway, the reason I've got the main board apart today, if we turn her over, I finally, after owning it for a while, it's now discontinued, and I've finally been able to actually get a service manual for it. Yamaha do not like releasing service manuals and schematics for models they still have in production, which is understandable. If you look, you can see there's some little bits of wire on these transistors. That's from about 6 months back. I tried tapping into the audio level, the line level circuitry inside. As you can bloody see, it's tiny, teeny tiny little. Let's see if I can actually focus in on one. See, let me get me just a mass of tiny traces and surface mount components everywhere. Well, I couldn't even read what was on this chip. Now I've got a service manual. I can actually make it out because I know what it says, but when it's got a big splodge of resin over it and it's in very dark print, I just could not figure out what it was. This little chip here on the bottom, this is the main audio level processing IC. So all the analog inputs that come in feed into this. It's digitally controlled from the main processor. All the digital audio decoding comes down in analog level into this chip as well. This then does your volume, bass, treble controls. It does your input selection, and it then traces its way off to the drive domain amplifier. When I got this amp, it didn't dawn on me till I actually brought the thing. It does, although it has a line level output on record, it's just it's bare audio. The volume control doesn't affect what goes on here. Bass, treble controls don't. All you can do with this, the whatever input you are using, feeds into this chip, feeds into the chip here, and part of it gets fed back. The actual chip itself actually uses that same signal. It loops it back round to go into the equalization and volume control circuits, and then feeds them out to the main amp. Well, I want to use this amp with different amplifiers and a subwoofer, and I've been having issues with wanting to actually do line level crossover, line level filtering, crossover network. Because this is just letting full level go through, I don't want to buy a separate DAC and then plug in through a crossover and then plug into this. So I did originally take this apart. My intention was going to be, I was going to tap into the actual analog feed going into the amplifier, break the tracks to this chip, send out the analog feed to, as you can see, I've unsoldered. I'm going to send out the analog feed to one of the, whichever one that comes out to be on the back, and then send back in. Now, I've had a think about it, and the amp actually is very basic on this, but the circuit tracks are so tiny. If I really put my mind to it and spent a long time doing it, I could probably knock something up so it actually works that way. But having a never think about it, to be honest, all I really need is to get the post equalization volume control output, because I can then feed that to another amp. I've got several amps I'm working on at the minute, so the amp on this is so simple. I mean, it is a really simple bare bones amplifier. I'll go into that in a bit, but I just figured it's so simple and it's so crappy an amp in terms of what an amplifier could be. I'm just going to not bother using it really. If I'm just watching some, few videos on YouTube or something on Netflix, I've got a speaker selection switch thing external to this. So it's not a speaker selector, it's an amp selector. It actually takes the output from the speakers into a little box I've got, and I can then switch between various amplifiers. It never connects any amplifiers together. It only ever connects the speakers I'm using to whichever amplifiers I want it connecting to. So this whole amplifier I'm just going to use mostly if I'm really wanting to listen to some music and stuff with the sub going. Then I'm going to take a feed out of this. It'll go into an active crossover network yet to be built. It's you know, future project. From that active crossover network, it will go into a second amplifier which will be driving the main speakers, and then another amplifier which is driving the subwoofer. It's going to help me eliminate a lot of various phase issues I'm having, obviously, with analog crossovers. If you're trying to use a crossover in parallel with a full range speaker setup, you get issues. You're just better off removing whatever frequencies you want from one set of speakers and putting them to the other ones. So anyway, yeah, I've had a good look around on this. Like I said, I finally got the service schematic, and if we look just so we can find it. Somewhere around the middle of where there's a little, I can't do this with free hands, somewhere near my finger, there we go, there's a little capacitor here, bloody focusing on it ever, and there's another one up here somewhere, and those are actually the main outputs from this chip. So I'm simply going to solder some shielded cable onto them. I'm still trying to figure out where I'm going to connect the earth to. I don't want to create a ground loop. I can't really go across the 2 points and just go onto the ground plane, because there's a good chance I'm just going to end up with lots of hum and noise. So I'm going to see if I can't come into where the main ground is for this whole chip and bring it out on these pins. So yeah, that's my plan anyway. So yeah, I'll have a go and we'll see how I get on. Okay, so again, back with the Yamaha, the RN-301. So this is what I've come up with now. Basically, this taps into the main output pins from here. It then feeds the output. I'm going to come out what was originally line 1 in. So I've had to do a few mods to allow this. First of all, I've made sure I've come after the capacitor coupling on the output. You don't want to direct connect to the output pins. There's some capacitors that go off to the amplifier. You can go after them. You don't have to worry about if you accidentally feed a signal in going to the amplifier, it damaging the amp, because there's some more capacitors that end as well. So yeah, there's various on all of these circuits. Obviously, the inputs all have a high frequency filter on them. It's just a couple of resistors and some low value capacitors. It just attenuates high frequencies from getting into the amp, like radio frequency noise and stuff. And the same again actually comes out of this chip before it goes off to the amp. So you have to make sure you come in direct after the output capacitors, but before the first resistor filter capacitor networks, which is sort of here and here somewhere. But yeah, you can see there's little small capacitors and stuff kicking around here. So those are the filter capacitors to the amp. This end of the board, you can see I actually soldered the connectors back in. On my previous try failed. I don't know if I mentioned that or not. I don't know what I tapped into, but it wasn't the signal traces, so I just uncoupled it in the end and, you know, didn't bother taking the amp apart any further. But now I actually have it this time, so they're soldered back in. The mess is just some flux on the board, obviously, because we're in a magnifying glass and surface mount components, it looks messy. But if you look, if it will focus, I'll get me tweezers. Where are you? There, where my tweezers are, is a small capacitor I've had to remove. And the same again the other side. Those capacitors are C211 and C210. They're part of the input filter stage. Obviously I want to remove them, otherwise as I'm trying to feed a signal out of here, it's just going to be shunting it into these capacitors. It's going to put load on this. It might affect the frequency response. It might make it oscillate or something. So remove that. The big capacitors which used to actually couple the line in stage to the chip, they're now out. They're just normal through hole components, so they've come out through the other side of the board. That's capacitor C243 and C242. They've been removed. So yeah, basically just a couple of small capacitors to be removed. And make sure again I've tapped in, so you can see I've tapped in where these capacitors used to actually go through the board. I've pushed the wires through, and that means they still actually go through a 470 ohm resistor on each side before it comes to the output. So that means if I connect some phono leads or anything to here, just like an op amp, you know, you don't just directly connect the output to your RCA plugs, phono plugs, whatever you want to call them, and take leads off, because the capacitance of the leads and, you know, various loads and stuff can play havoc with the chips and force them to oscillate. So I've just removed the capacitors from the input filter circuits, but I've actually left the resistors in there. A little higher than perfect, you know, you'd rather do 100 ohms, but 470 is going to have no overall negative effect on the output of what's coming out of the amplifier. So, yeah, we'll turn it back over. And, yeah, you'd never know. They're all back in. I actually now have my CD line, which I never use anyway, but that is now coupled back up. So, yeah, I did mention about this amplifier being a really crappy design. Well, for fuck's sake, focus. It's actually a quasi-complementary symmetry design. It uses all N-type output transistors. There's no complementary pair at all. I mean, that's like... You had transistors. The first transistors, germaniums, were mostly P-types, the power transistors. So you used to have an all P-type output stage. Anyway, silicon come along, it sort of cheap in the 70s, and you had all N-channel. N-channel ones were far more reliable and you know, just worked far better than P-type. And the classic stage called a quasi-complementary, however you want to pronounce it, complementary symmetry output stage, which basically just used all of one kind of output. There's just crap all over here. Yeah, just used all one kind of output transistor. One's outputting is an emitter follower, the other's outputting is a complementary feedback pair, or cycle, again, however you want to pronounce it. Now, it can be made to work quite well. You have things called the Baxendale diode mod. This doesn't have that. This is the long tail pair on the input. It's not fed from a proper constant current source or sink. I can't remember if they're P or N type. I think they're P type, so it would be a source. It's just got a proper, genuine, old school resistive bias network in the tail of them, which, you know, isn't great. There's no current mirror on the long tail pair. Again, one just shunts straight to the negative rail. The other's just got a small resistor, and it couples to the base of the voltage amplifier stage. Voltage amplifier stage is a single transistor stage. There is no active semiconductor load in it. It's just bootstrapped from the output. And then finally, and it does make me laugh, the short circuit protection on this amp is not short circuit protection. There is no protection for any of these output transistors. All there is, on the negative side only, if you overload the amp past a certain amount of current, it is the amount of current you can put for it changes with the amount of voltage on the output, because there is a diode sort of attenuation network, which obviously allows you to, as you've got more voltage, you can allow more current because there's less voltage across the output device, so there's less power being dissipated in it for any given current. So it does allow for that, but it doesn't monitor the positive transistor at all. It just monitors the lower one in the CFP configured N-type transistor. And if you short the output or overload it, there's no instantaneous clamping. You know, normally a short circuit protection, there's many ways of doing it, but what you'll do is you'll monitor both the voltage across and power through the output transistors. Obviously so basically you can stay within a power curve, power ellipse, and if at any point any load exceeds that, you actually have active circuitry kicks in and basically stops the amp from trying to feed any more power into the load. You know, it's actually designed to limit the amount of power the output stage transistors dissipate. Well, this doesn't do that. If you short the output, the top one can go full power happily, you know, nothing to stop it whatsoever, and the bottom one will as well. All that happens is a small transistor turns on, which feeds a signal to the little microprocessor that's in the amplifier, and that shuts down the power supply. Well, the whole time that's going on, that still takes time. And in terms of how fast, you know, your output stages are going between rails, and, you know, how long a short circuit, there's no way that that is going to work quick enough under most conditions to actually protect these. It's all right if you got maybe too many speakers or something wide, but short circuit, you might get away with it once or twice, but I wouldn't count my luck. Eventually you'll just blow your output transistors up. So if it hadn't been, look, it doesn't look too bad this side, but when you go this side, you can see everything is so crammed in there. I would have been tempted and I am tempted, but I can't be bothered with the work. Like I say, I'm going to run Ever amps anyway. This is mostly this board now. It's just going to be for light telly listening in at background level where I don't really need the power and, you know, the sort of better output stages. I just need a basic amplifier to drive some speakers. And then this is fine. This will do. If I'd really wanted to keep using this amp, I would have, you know, bare minimum, I would have converted this to a proper complementary stage. But it's just too much crap rammed in there, so I just can't be bothered. I'll tell you what you could do. I mean, yeah, there's no, if you notice, there's no potentiometers either to adjust the V bias. There's just a static resistor network and a transistor. You could do on this amp, and I might do it at some point once I got my other stuff up and running. I've got a lot of projects on it. I'm waiting for circuit boards to come back from China, from America, all over the place. Things I've sent off for fab. When they turn up, I've got to put all the bits on them. I've got a hell of a lot of work in the next couple of months to get my projects I've been working on up and going. So this is just whilst I'm waiting for bits, sort of little one that's been on the back burner for a while, which I can now get round to doing. But these, the pin out on these, not the, you can get two kinds of big, these are TO247 cased package transistors. You can get the bipolar, obviously bipolar transistors or EGFETs, various other kinds, but you can get MOSFETs as well. Now, the lateral channel MOSFETs, which are actually designed for audio, have a different pin out there to stop you from trying to, if they break, I'm guessing it's to stop you from trying to just put cheaper switching or power supply MOSFETs in. However, the power supply MOSFETs follow the same pin out, as it were. Obviously, on these TO247s, you have base, collector, emitter. Well, the power MOSFETs, they go gate, drain, source. So this would lead itself quite well for changing these out, you know, just removing a V-bias network, putting a couple of Zener diodes in to clamp from the gate terminal to the source, and just putting a potentiometer in the voltage amplifier stage to adjust the bias and a diode or two just to firmly track it. So, you know, obviously one of these would bolt the upper transistor, the N-type one would be a pin-for-pin replacement. The lower one, you'd have to just swap your two middle pins, your middle pin and your outer pin. But I think I could go make this into an IRFP240, IRFP9240 vertical channel MOSFET source follower output stage. And I think I'm going to do it. Like I say, it's going to be a while yet. I'm going to get all my other stuff sorted. But I think, yeah, because it's such a shitty basic amp, and then, yeah, I've got no problem pulling this thing apart at all and actually doing something decent with it. So anyway, I'll put it all back together and give it a test. You know, I've kept saying this is all good, this is working now, but one thing I haven't actually done is tested it. I've just gone on the assumption that I've checked again, and then checked some more. Everything I've done is correct, so it should work. So fingers crossed, we shall find out. Right, well, success. She's back together, and yeah, I now have, look, if you listen, I start to turn the volume up. As you can see, there's no speakers connected. I'm simply coming from a Chromecast audio into the CD input, and my what used to be line 1 in is now, you see that's feeding into my little valve amp over here. So yeah, I now have the job done. Yep, just had to check then. I seem to have lost my left speaker, but it turned out I just didn't have the lead plugged in. So yeah, as I was saying, if I ooh, distortion. So yeah, I now have preamp output. So yeah, future projects, I can now simply just come out. I've got me see, I've got the optical inputs and the SPDIF So I can use this amp for decoding digital audio from various sources, be it because the Chromecast audio will actually put out on a optical output, mini optical, rather than using the analog output. So yeah, I've got what I achieved, really. Got what I set out to achieve. So yeah, not bad. Only took a couple of hours. So yeah, if you think you've got the skill to do something like this, it's not really hard. There's no electronics involved. You've literally got to remove 4 capacitors and solder a few bits of wire across. Job done. Perfect.